All right, let's dive right into this explainer. Welcome to our Biology 9700 Vmax and KM exam strategy autopsy. Today, we are going to expose exactly what separates a solid B grade from an elite A star when you're tackling Vmax and Michaelis Menten constant questions in your Cambridge exams. We're skipping all the fluff today, you guys. We're going straight into the examiner's mind to look at the exact mechanics of how marks are awarded and, honestly, more importantly, how they're lost.
So, we're jumping straight in with a question. What is the one tiny, mark-costing mistake that is destroying top grades? It's a catastrophic error that shocks confident students every single year and completely ruins grade boundaries. Just imagine walking out of the exam hall feeling like you absolutely nailed the enzyme kinetics section, only to get your results and realize you dropped a whole grade bracket. No way, right? Why does that happen? What is this invisible hurdle?
Well, it's the classic trap, using the wrong terminology for the wrong context. The crucial point here is that ordinary rote revision kind of fails. Why? Because you might spend hours memorizing generic textbook definitions, but then you fall directly into the examiner's trap. You provide answers that are perfectly memorized, but completely irrelevant to the specific question context. Like, you might know exactly what Vmax is, but if you don't apply it to the specific enzyme inhibitor scenario given in the question, you're going to score 0.
To sidestep this trap entirely, we really have to understand the core principles. Take the Michaelis Menten constant, or Km. It isn't just a random number you cram into your head. It's a fundamental concept, and its theoretical architecture rests on precise definitions, causal relationships, and integration with other syllabus areas. The top-performing candidates, they exhibit a connected, conceptual understanding of Km that transfers perfectly to unfamiliar contexts. They don't just know the math, they know what the math actually means for the biological system.
Actually, don't just take my word for it. Look at this quote straight from the Cambridge Principal Examiner report. Candidates referencing cross-topic connections achieve significantly higher marks. This brilliantly illustrates what the examiners are actually looking for. The assessment framework prioritizes analytical depth and evidence-based reasoning over superficial breadth. They want to see that you can link, say, enzyme affinity to protein structure or to cellular transport mechanisms, depending on whatever data they give you.
Now, in just a moment, I'm going to show you the exact examiner clue that changes your answer completely. It's a real game changer for top band marks. But before we reveal it, we have to build the procedural framework, because without it, even the best clues just look like extra words on a page.
And that brings us to number 3. Let's look at the top 3 mistakes explicitly warned about in those principal examiner reports.
Boom, here they are. The ultimate grade killers. Examiners repeatedly deduct marks for these 3 specific errors. Number 1, using the wrong terminology for the context. Number 2, literally just forgetting to check your units, especially when you're calculating reaction rates, and mixing up your terminology. And number 3, providing answers that just aren't specific to the given context. They are practically begging students to rigorously check their units and directly link their analysis to the scenario on the page, not some hypothetical one from a textbook.
So how do we fix this? We use the method mark strategy, which is all about process over final answer.
This is absolutely crucial. Cambridge awards critical marks for your logical process, even if your final calculation goes slightly awry. Notice how this workflow breaks problem-solving down into a completely repeatable system. Step 1, deconstruct the question so you know exactly what they want. Step 2, extract the relevant data from all that overwhelming text they give you. Step 3, select your analytical framework. Step 4, execute your analysis with crystal-clear notation. And finally, Step 5, present your final answer using the correct terminology. It's like a giant puzzle, and this is how you solve it step by step.
Let's do a quick pause and predict. Active recall time. Imagine you're sitting in the exam right now. You've got an experiment comparing the mean reaction rates of an enzyme at 2 different substrate concentrations to figure out Km. Think about it. Which statistical test fits this specific scenario? Lock in your answer before I reveal it.
Okay, if you predicted the t-test, you are perfectly applying the analytical framework required for those higher-order marks. As you can see, the t-test is specifically for comparing means, whereas chi-squared is for categorical data and correlation tests are for relationships between variables. Picking the right tool right out of the gate proves to the examiner that you have that analytical depth.
All right, diagnostic checkpoint. Let's play spot the error. Look at this incredibly flawed student answer. The enzyme had a lower Km, so it worked better and was faster. Read that carefully. Can you spot exactly why a Cambridge examiner would reach for their red pen and penalize this immediately?
It's literally night and day when you compare them.
The flawed answer says lower km, so it worked better. But the top band response? It says a lower km indicates a higher affinity for the specific substrate in this context, requiring a lower concentration to reach half Vmax. You can see how the improved version executes clear notation, completely removes vague, non-scientific words like better or faster, and presents correct, context-specific terminology. That top band answer achieves maximum marks because it follows this exact comparative analysis checklist. Whenever you're asked to evaluate or compare, you must identify both similarities and differences. You've got to use comparative connectives like whereas or however. You have to support every single claim with actual evidence extracted from the data. And finally, draw conclusions on relative importance.
And that brings us to this massive examiner alert. Always link every point to the given scenario. This locks in the ultimate rule for sure. Generic answers will cost you your A-star. Let this be a flashing alarm bell in your mind during the exam. Every single piece of data you pull, every theoretical principle you apply, it all must tie back directly to the unique scenario sitting in front of you.
Okay, but picture this. We've fixed your terminology. We've established your analytical framework. But what if your Vmax and Km calculations are flawless? Your context is perfect, but you fundamentally misread the command word that decides your mark band. This is a massive unresolved problem that could still completely tank your score. What if your biology is perfect, but you misread the one tiny word at the start of the question that tells the examiner exactly how to grade you?
You see, command words are the ultimate gatekeepers of the mark scheme. Without mastering them, even perfect biological knowledge can score a big fat 0. So to discover the specific command words that dictate the mark band and to solve this final mystery, you absolutely must watch the next explainer right now. Make sure you subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to completely bulletproof your exam strategy. We'll see you in the next masterclass.